Hey, FMT100. We're looking at section 7.6. This happens to be bearing failures. So, yeah, uh, it happens. Walk a facility, and I guarantee you at some point you're going to hear this funky, high pitch, squealy sound. And that's usually an indicator of a bearing deciding to end its life. Um, the sound will continue. It will the pitch will get higher. It'll get it's a metallic screeching, and then at some point it's going to be grinding, and you'll actually hear the piece of equipment become unbalanced because as the bearing fails, the roller elements all kind of shift on one side. Kind of think of it like when a wash machine, you go on the spin cycle and all the clothes kind of go on one side and you get this rump, rump, rump. The same thing will happen as a bearing fails. All the roller elements get kind of stuck on one side, or they kind of go in groups around, and it's going to cause your whatever spinning, blower, pump, whatever. It's gonna have this wallop sound. I think that's the best way to describe it. Yes, Wallop. Wallop. Yes, yes. So that's what it's going to sound like. And bearings fail. It's a moving piece of a machinery. It's going to end up failing. Now, where we can make a difference is if we properly install them. That will make a huge difference because then we're not doing any damage to the bearing before even operation. So once again, properly install the bearings. Now, during operation, there's a couple things we need to make sure of. A, we don't operate that bearing above the temperature that the manufacturer would like to see that bearing to operate. Always give yourself tens of degrees of room, if you can, between your operating temp and the max temp for that bearing. Moisture is like the huge, huge enemy of bearings. So we're always going to try and make sure our bearings are sealed or at least protected from moisture. And if we're protecting it from moisture, pretty much guaranteed we're looking at keeping it protected from contamination. Contamination is anything that'll enter the bearing. Once again, so if we got an open bearing, we need to make sure that that open bearing has some type of cover over it. Hopefully it's inside a housing so we can make sure dirt, debris, and moisture does not get into it. If it's an open bearing and we don't have such an ideal condition inside a housing, we've just got a cover over it, and which does happen, then we're going to make sure that that cover is intact and that no debris has made it past the cover and is inside our raceway and messing with our roller elements. One of the ways we do that is we properly lubricate our bearings. If we properly lubricate, we are replacing the old grease with new grease if it happens to be a grease type bearing. And by doing that, we literally flush the lubricant, the old grease out, which will contain the contaminants. If it's lube oil, we always make sure there's enough lube oil in the system. And while we're not getting rid of the contaminants, well, what we are doing is we're diluting the contaminants. We are providing more oil than part per contaminant kind of deal. So that's how we're doing it with lube oil. So we've got those areas. The other fun one, which we will tend to see if we've got a motor that is deciding not to be with us much longer, and or we've got a motor that's operating off a variable frequency drive, a VFD. And typically we'll see electric current flowing through the bearing when the motor is being operated with a VFD. And this is typically lower end motors that don't have the good enough insulation on them to deal with some of the high voltage spikes that are created when you're using a VFD. And what will happen is we've got a couple things going on. So we can actually have a stray current build up on the armature, which is the shaft of the motor. And if that happens, then that stray voltage will find the easiest way to go to the other side. And in this case, it's going to be through the bearing. And when that happens, when we have electric current flowing through the bearings, it tends to etch the bearings, not only the the inner and outer rings, but also the roller elements themselves. So it's etching both, and it's really fine pitting is what it'll look like. And it's always wherever the roller elements are making contact with the inner and outer ring. The other area where bearings fail is overloading or excessive thrust. And overloading could be you just put more load, you put more boxes on a conveyor than normal. You put more load on a belt or pulley. You put more heads, static head on a water pump than the water pump is designed for. All those things will cause us excessive loading and excessive thrust. Now, the other area where you start getting into excessive loading is if you have improper alignment with your driver and your driven shafts. So if you have improper alignment, that will also cause overloading. And the fun news is that's going to be covered in the next section. So I know it's kind of a fun segue, and I'm going to use it. But that is another reason for a bearing to fail. So some of the symptoms, we already said electrical pitting, the fluting. You'll get this really strange. Oh God, how did the book describe it? It's one of those deals where if you see it, you know what it is. You're like, oh yeah, that's no bueno. But galling is literally a buildup of metals on metals. That always sucks. And that's literally one metal peeling the metal off another and adding it to itself. That's always fun. The false Brinell damage, that is the bearing's not moving. So for spalling, you get this etching and this buildup of metal on metal, and you'll see metal being torn out of places. But that's during operation. The bearing has to be moving for that to happen, along with galling. False Brinell damage is the bearing is not moving, it's stationary, but there's vibrations. And it's literally this, it's vibrations where because the bearing's allowed to sit there and vibrate, the roller elements basically just sit on one spot of the rings and essentially just compress those areas. And so there'll be like this fine dimpling effect. So that is not good. The other, yeah, so fluting is when I had to look at them like, how do you describe it? So it's when the inner and outer rings make contact. So yeah. So that's, and it's for that the rings themselves start to gouge away, and they'll open up a little bit. It's you'll see it once and you'll go, holy crap, that's what he's talking about. Yes. And like I said, I'm trying to find good images for this stuff. Searching the net just gets me a ton of stuff that's not right. If you happen to find anything, if you're like, well, damn it, I'm going to search the web for these things. Hey, awesome. I was not that successful. If you guys happen to go about and find stuff, kick me over the image. All right, please, because I will share it with class and we'll go from there. And I will share it with future classes as well. So, all right, that is it, because the next screen is going to be all black, meaning we got rid of bearings. All right, and we're going to be moving on to shaft alignments. And as I said, already equally important. So we will go from there. All right, catch you on the flip.